Hi guys, today we're going to be going through how to arrange X objects in n spaces where X objects must be together. An example of this question would be if 3 rowers would be placed in a boat of 6 and these 3 rowers had to be together, how many ways could this be done? So this is the formula. I'll explain this formula. So first of all, if these 3 rowers have to be together, they can be in these 3 spots, these 3 spots, these 3 spots, and also these 3 spots. So that is where the n minus x plus 1 comes in. So in this case, it would be 6 minus 3 plus 1. So there's 4 ways that you can put these 3 spots in the 6 rowing spots. And the x factorial comes in, where you have to figure out how many ways these 3 people can be arranged. So 3 people could be in the first spot, 2 people could be in the second spot, and 1 could be in the last spot.
So in this question, how many ways can you arrange A and B in a 4-letter word where A and B need to be together? So we'll start off by writing the rule, which is x factorial times n minus x plus 1. So in this case, x is the number of objects and n is the number of spaces. So in this case, we have 2 objects. So x is equal to 2, and it's a 4-letter word, so n is equal to 4. So now we'll just sub in those values. So 2 permutation times, so n minus x plus 1, so 4 minus 2 is 2 plus 1 is 3. So it's just 2 permutation times 3, which is 6. So in how many ways can you arrange A and B in a 4-letter word if A and B need to be together? So remembering our rule, in this case x is equal to 2 and n is equal to 4. So now we'll just sub in those values into our rule. So 2 factorial times n minus x plus 1, so that's 3. So that ends up being 2 times 3, which is equal to 6. So how many ways can you arrange the word maths where M and A must be together? So we're going to use our original rule to find out how many ways M and A can be arranged, and then we're going to have to use a different rule to find out how many ways the remaining 3 letters can be arranged. So our rule, x factorial times n minus x plus 1 covers how many ways M and A can be arranged. So we're going to add on n minus x factorial to find out how many ways the remaining 3 letters can be arranged. So we're just going to simplify this rule into x factorial times n minus x plus 1 factorial to answer this question. So in this case, how many ways can you arrange MA in the words maths? So x is equal to 2 because we have 2 letters, and then n is equal to 5. So now we're going to sub that into our rule. So 2 factorial times n minus x plus 1 factorial. So it'll be 5 minus 2 plus 1 factorial. So that's equal to 2 factorial times, so 5 minus 2 is 3 plus 1 is 4, times 4 factorial. So 2 factorial is 2 times 4 times 3 times 2, so that's 12, so that's 24. So our answer is 48.
In this question, they're asking how many ways can 8 rowers be arranged in a boat of 4 where Mark and Dhruv must be together, because they love each other so much. The first part of our question would be figuring out how many ways Mark and Dhruv can be arranged together. So that'll be our original rule, x factorial times n minus x plus 1. And the second part of our question would be figuring out how many ways the remaining 2 spots can be arranged. So there's 2 spots because n minus x, because there's n spots in the boat, x have already been taken, and we'll introduce a new variable s, which is the total number of rowers available, 8. So s minus x, because there's 6 rowers left available. And we'll do a permutation and add it on. So then, subbing in our values here, x factorial would be 2 factorial, n minus x plus 1 would be 3, and s minus x would be 6 permute 2. So here we have 2 times 3 times 6 times 5 times is equal to 30. And here we have our answer, 108. Thank you for tuning in.